So hello everyone, my name is Hunter, and this is Mark, and we work at Tlon. We've basically, rebuilt our product a bunch of times, and starting about like 2.5 years ago, we started on this journey of basically, how do you build a real product on Urbit, and what does it take? We've basically had to build everything that we, every tool that we need along the way. This is all in Gall. Hopefully Shrubbery can help us get, a little further, but either way, we've had to build a lot of tools. So yeah. You ready?
So when building product, we didn't have any of these goals explicitly in mind. We never sat down to be like, oh, here's the list of things we're all aiming for. But looking back, all of the crazy stuff we had to do to make a reliable product on Urbit kind of slots into one or maybe multiple of these categories. And so you'll see us tie these into the things we're going to talk about. I'll just cover them briefly here. User experience, of course, is at the very top. The user experience of a product is king. The product has to work well, and it has to be easy to use it well. This is not just the use of the product itself, but also how you get onboarded into the product, how the product communicates to you, etc. And so most of these other points kind of all, point up at this, the core of building a good user experience. Stability, for example, means that the product has to work well consistently. Something that works well only some of the time is actually worse than something that feels really off, but at least is consistent in its behavior. Performance, similarly, says that it has to work well fast. Even if it's an otherwise really nice experience, if you're waiting 10 seconds every time you navigate to a different screen or press a button or whatever, that's just not going to cut it, right? So performance is very important for achieving good user experience. Legibility says that when your product ever doesn't work well, it has to be legible to the user about what's actually going on, maybe even explain why it's not working well, or what the user can do to resolve that situation. And lastly, maintainability is about the product being workable for us, because we have to work with it every day, implement new features, and not, we don't want to be in a position where we have to do the 6-month backend rewrite every single time we change something about how the product needs to operate.
The first thing we're going to talk about is lure, which you may have heard of, but maybe not. Basically, 2 years ago, we're sitting at an offsite, and we were like, what's the actual problem today of, how do we get people here? And we just didn't have an answer for that. And so we came up with Lure, which is a service that kind of generically lets you basically poke stuff into somebody's ship as they come online, and it can connect the dots of okay, this person was invited, through this channel, so we're going to do these actions or whatever. And this allowed us to basically, not just plop someone on a hosting page that they have no conception of what Urbit is. It's there's just no context. So they needed something, it's someone invited you to this group, or you found a link about X that led you somewhere. Because the eternal problem was how do you get on Urbit? And then once you're there, it's why are you getting on Urbit? Well, it's probably to talk to someone that you know, or something you found. And then kind of this last question, what do I do when I get there, is an ongoing kind of struggle that we're starting to develop stuff for. You should be able to find people on Urbit when you get there. And we just don't have that yet. So, yeah. So another, like, this one's kind of like halfway a developer thing, halfway like a user experience thing, which is like, you know, on Web 2, if you go to a UI, generally that means the service is working. Like if the UI is present, then, you know, most of the time it's working. There's exceptions, obviously. And in Urbit, that's not always the case, right? Your ship could be offline. Someone that you're trying to talk to ship could be offline. And so there's all these problems that like people don't normally encounter with traditional software. So, you know, we get a lot of like, you know, why can't I talk to this person type of problems. Finally, we had enough of it, and we were like, okay, we need to make something that can tell us exactly where the communication is breaking down. Because without that, like, it's, I mean, it's like hours and hours of just like poking random stuff manually to try to figure out, okay, can this ship hide that ship? Can that ship hide this ship? And that's too much, right? So we created a thread called Vitals, which basically runs through a checklist of like, can I talk to DNS at all? Can I talk to, you know, the sponsor, my sponsor? Can I talk to the sponsor of the person I'm trying to talk to? Can their sponsor talk to them, right? And then, you know, the most basic part of that is just like, can I hide the ship at all? If we get that, then we kind of like cut out.
How can you tell whether their sponsor can talk to?
That's a good question. I didn't write Vitals, so let's see, like Alex would be a good person to talk to, Shakalnikov. You know, so we needed this to show in the UI, like if you're in a group and the host is offline, right, you need to know why your messages aren't going through. Now, of course, like we could develop something that makes groups more resilient and like the host doesn't need to be online. But there's always going to be some case where like something breaks down and there's like no communication. So we need to be able to display not just that it's broken, but like why it's broken. And this leads into like what Mark's about to talk about, which is versioning. So like, you know, if your ship upgrades your chat app and it's on a new version, you know, unless we're really good about backwards compatibility, like you probably can't talk. And so we need to be able to show you like why that's the case. You know, we need to, like Mark was saying earlier, like we need to handle the difference in experience by just telling you what's happening. Because otherwise you just have no idea and it's like, it's broken, I don't want to use this anymore, like bye. You know, so it's all about user experience.
So yeah, part of the legibility story for connectivity is in the versioning story, where it's like, okay, maybe I can talk to this guy, but are we like speaking the same language still, or did you upgrade, or did you not upgrade yet? We've done a number of different approaches to this over the years. What we settled on doing for the most recent rewrite was a genericized one-way version negotiation between agents. This is the dumb approach. We don't get very fancy here with like, oh, if you're like a protocol ahead, you can like upgrade messages from older protocols or anything like that. We just say you're either at the same version or you're not, and then you can talk or you cannot. We bundle this up into a wrapper agent library, libnegotiate, which wraps around the agent that you're writing. You give it, for yourself, a list of protocols and their versions that you're exposing externally. And then for every unique agent name that you talk to, you also specify a list of the versions of the protocols that you expect them to expose. When your agent emits a watch, a subscription to another agent that's in that compatibility checklist, the library actually holds on to that subscription before releasing it, and first does a version check with the external agent, asking what version of this protocol that I care about are you on? If that comes back and it's a version that we don't know anything about, or it's like not the version we expect at least, the subscription just stays there in stasis. As far as the inner agent is concerned, it just hasn't gone through yet. When the other side eventually upgrades and sends a notification to us, I'm at a new version for this protocol, we can now see that we match. The library releases the subscription, and that just proceeds through the subscription flow as normal. This way, the inner agent does not have to worry about receiving facts that it doesn't know how to support. And it doesn't have to worry about the other agent saying, this is a subscription, but I don't know what you're asking for. This lets us distinguish also between the failure cases for Gall subscriptions, where Gall doesn't really give you enough information to distinguish between, is this a protocol level failure, or is the resource just not found? This way we can always know, oh, we're on the same version, so if they reject our subscription, the resource just doesn't exist. Again, this is the dumb approach. You could get a lot fancier here, but in practice, for our use cases, now that our protocols have kind of settled in, the breaking changes here aren't that common anymore, and so we can get away with this.
So similar to struggles with different versions on different Urbits, like we have the same problem with clients, right? Because if you're running a production app, then inevitably someone's on some old iPhone and they turned off updates and yada yada, or any number of things could happen. And not just that, like other Urbit agents that are trying to consume our data, they're kind of clients. And so what we've done is try to basically map one-to-one, like this path at this version is always going to give this mark, which is always going to correspond to one data type. And we don't change that. So every scry has a version path. Every subscription has a version path. That way, like any old clients will still get the data that they expect because they're still subscribed to version 1 of the path. This allows us to not worry too much about updating existing apps because we know that the front end isn't going to just immediately break. Even if, because we ship a front end when we OTA the code, but and we give you a little dot that's you need to update, and you click that and it updates. But things can happen that can fail or go wrong, and then if your client just broke because the OTA went out, then that's not a good experience at all. So that's just kind of a discipline thing, and most normal software companies go through this. So it's just standard API versioning, but it's just something that wasn't it wasn't part of our ethos for a long time. So we're trying to get better.
One other thing we've been continuously trying to get better at is actually writing tests for all our software. There really is no replacement for end-to-end integration tests, and a lot of that you still have to do manually at the end of the day. You do have to hammer on the product in a real environment and see what happens with it. But for some things, like the version negotiation library, for example, it's just a state machine. It's simple enough that we can enumerate all the states and the transitions between them, and so you just want to write tests for all of those. A problem there is that that's all agent code that you want to be testing. So it's speaking the Gall, interface the Gall API, but we historically haven't written very many tests with those kinds of code bases. It's always been unit tests on individual functions and stuff like that. Some time ago, I think, around summer of last year, Philip Monk rewrote the air tests for me because I was getting fed up with them. Every small change involved, very rote, but a lot of changes to the air tests to make sure they all still pass, because I know I didn't touch that functionality, but somehow the test results still changed, right? he rewrote them in the continuation passing style, which turned out to be very ergonomic for writing those kinds of tests, actually. You set a little scry helper for like, oh, if air scries, like for these things, like give it these results, and then you just walk through the life cycle of the thing sequentially. I wanted to do the same for agent code. But agents make actual non-trivial assumptions about the environment they run in. Gall does a bunch of bookkeeping for them with relation to their subscriptions and other outstanding I/O that gets reflected in the bowl, and the agent then looks at the bowl to see like, oh, did I already send this out? What's my behavior supposed to be in this specific scenario? The trick here was taking the lifecycle functions of an agent and making them utility functions for your testing library. So we have a very, very contrived example here where we start out by calling load on an agent core with some custom state that we just invented, right? So right away, it's as if your agent just came from an upgrade path. It comes into existence with all this state that I purpose crafted for this specific test. We then set the source in the bowl to pretend that we're Zod talking to this agent. And we do a poke. With a noun, we give it something. And out of that, of course, comes not just the updated agent core, which keeps getting passed on in the continuation, but also the effects, the cards emitted by the agent. We have an xcards helper that takes a list of cards and a list of functions that test those cards for expected contents values to whatever level of granularity that we need. In this case, we're expecting a single watch coming out of the agent. We call another helper for getting the current state out of the agent. The stuff that comes out of onSave goes into onload, and then we do an equality test on a subset of that. In this time, when we did the poke and the watch came out, the helper library did the bookkeeping in the bowl to register the subscription as, oh, this is a subscription you made. It's not act yet, but it's there, right? When we then do an on-agent for that subscription and give a watch act, the first thing the library helper does is update the bowl and then call the agent. So it's a realistic situation of like, oh, I did get a watch act, and that's reflected in the bowl, so none of my assumptions are violated. We again check for cards. We have none. Get the state, check it again. This is actually a really nice way of writing, like testing out different flows with your agent. And all of these functions come stock with the libtestagent library, but for your specific use case, it's trivial to write a helper. For example, here we check the want.state, a couple times over. You can easily pack that up into a helper where you just say like test want, and you give it a value, and it like pulls that out of the agent for you, tests it, and then moves on. Some of you might be thinking, we've done this before, right? What about Aqua? But Aqua simulates an entire Urbit, all of the kernel things, all of that behavior. It hasn't been that well maintained over the years because it hasn't been used that much. And for like all of the cases that we care about, just simulating the way that Gall interacts with the agents it's running is more than sufficient. Oh, this is also me, actually. Psych. One other thing that's been difficult over the years is gaining insight into what is actually going on with all these agents running on all these ships. libverb has existed for a while. You can turn it on, and your agent will spit transient output out into the terminal. And you can look at it, and you better look at it, because it's there and it disappears before you know it. It doesn't even give you that much detail, right? What you see here is a demo video of debug dashboard representation of verb plus logs that were added in Zeus 411K second release, thereabouts. What we did is we updated the libverb library with a new endpoint that instead of just slogging high-level information about an event into the terminal, it gives them out as subscription updates. And these are very detailed descriptions of the events happening to the agent. So for a poke, for example, it gives you the source and the mark that it's getting poked with, and the mug hash of the content going into the agent. And when that processing is done, it takes the effects coming out of the agent, does similar granular descriptions of those, and emits them as subscription updates also. We additionally added an agent that can subscribe to that verb endpoint on any arbitrary agent and serialize it out to disk on Unix. What you saw on the debug dashboard just now was both connecting to agents running on your ship and look for getting that verb output and visualizing it, and also loading in one of those files that was written to Unix for a longer, more persistent view into the history of how that agent behaved. With this kind of view into that activity and the events that come out of your agent, it's much easier to correlate activity happening between agents on the same ship and even agents between ships. At Tlon, we have this now turned on for all our ships that are hosting big groups. And it's been interesting to see the ebb and flow of the activity and being able to notice, like, oh, someone sent a message here, but like all this stuff suddenly happened. Like we need to look into what's actually going on there. It's a kind of visibility we haven't had before. It's proven useful.
Thanks. And just a small note on that. What spawned this coming into existence was we had one of our groups make a very small change to roles, which then generated like almost 1.5 billion events, just from like the cascade of like, you know, things being updated and coming back around. So, you know, hopefully this will help debug all that class of issue.
Is this on the debug dashboard?
Yep.
This is on the debug dashboard as of 4.11.
Oh, that's awesome.
Yep. Like as long as the agent you're trying to do it with has the new libverb, it just works.
Oh, that's so cool. Okay.
All right.
Yeah.
So last year, I guess early last year, we started to feel like really the weight of our refactor, or the original group's rewrite. And so the problem here was that we had these data types, which you use to do actions like send chats, but it also used that same data type to then relay that information to the host and then back down to subscribers and back to your ship. The problem here is that in that chain of events, we had no idea, based on the data type, like at what point you were in this process. And since all those things were part of the same process, they all had to be in the same code path, which meant that like the way that we handled, you know, syncing a backlog ends up displaying, you know, coming through to the front end, and so your front end might lock up because you're getting thousands of messages from, you know, a host or whatever. So, you know, at Philip Monk's house, we sat down for a week, and we came up with this 7 things model. So basically, you have a client, a subscriber, and a publisher. You know, a client is like your front end, right? A subscriber is like your Urbit that's listening to a group host, you know, a publisher. And then for each of the, you know, steps in this flow, we have one data type that corresponds with that. And that way, like, we're much more easily able to segment, okay, actions can be, you know, all of commands plus only the things that should affect my ship, right? So we get this like nice like segmentation. And then, you know, similarly, like we also limit what can be done with a publisher because it's only this subset of commands. And then like, on the flip side, when you're doing actions and commands, like you might not have all the data yet because the server has to do something. And so you want that, you want a different data type for the response. And a lot of our data types were sharing kind of the same general contents between the action and the update. So we had a lot of struggles with like trying to add, data to these types and ended up, shooting ourselves in the foot basically. So this just leads to like a lot better like maintainability essentially. And if we have to do updates, like it'll be a lot easier, to transition to a new update in this model.
One of the things that came up during the refactor was dealing with content that might change over time but remain at the same identifier. So obviously like editing or deleting posts in chat channels, right? It's so easy to get tempted into trusting yourself, being like, oh yeah, we have this whole complicated situation where you can like get data from snapshots, or you might get a log of diffs instead and you just apply them in the right order and it'll be fine. It will not be fine. Don't do it. Don't be clever. Don't trust yourself. Just do the dumb thing. Slap a revision number on your piece of content. When you delete it, leave a little deletion marker there. And then only apply changes when it makes sense to do so. It's trivial, it's reliable, it just works.
What do you mean only apply changes?
So if for whatever reason you get a diff that says like, oh, here's an edit to this thing, and the revision number is 5, but I know of a version of this, or like I know my version of this is already at revision number 7, I'm not applying that edit, right? I just keep what I have because I know it's newer.
It's like CRDTs, basically.
It's dumb, right? Just nice. It's good. Another thing where it helps to be dumb is managing I/O going out of your agents. Historically, we've always had a lot of implicit state in outstanding subscriptions, like is it pending, yes or no? Like, do we still care to maintain this, yes or no? We would put, like data that we care about in the wire, and like it'll come back to us eventually. Also not good. What we ended up finding is that it's very nice to have what we call an Inflate IO arm, which you can just call at any time. And you say, I track information about what subscriptions I want in state. So at any moment in time, your agent can just like call that arm. It'll see in the bowl what subscriptions are actually there. It'll compare that against your known desired I/O that's described in state. And then you just fix the difference. This is especially useful during migration scenarios where sometimes the entire way you set up your subscriptions in the first place changes radically. This gives you a very easy point to just put all the logic for like, yeah, you just tear it down. We know we don't care about this. And yeah, you put this in, you establish this back up because we now know like from our state, we just derive the knowledge that we care about it. There was some discussion about updating Gall to make all I/O declarative, where an agent would sort of like write into the bowl to declare what subscriptions it wants, and then Gall would take care of it from there. Shrubbery sort of has this idea where it's like, yeah, you like write down, you explicitly declare like all your dependencies, and it does that in a more static feeling way instead of implicit in the behavior of your code.
I think everybody knows that, Urbit's perception originally was that it was slow, Urbit, give it a minute, etc. So we've done a lot of work to make our app as fast as we can. This is just kind of like a miscellaneous list of things that we've done, but it might be helpful for those of you out there who are trying to actually make something that people want to use. So the first one is mark warming with FazBuck. So if you're unfamiliar, like scries can't write state. So what happens is you go and write some data type and you make a new mark for it and you write a JSON arm which converts it and everything's fine, right? And then one day you realize like all your requests are taking like way too long. And the problem is that the compilation for the conversion of the mark to JSON is not actually cached because scries can't write to the cache. So the way around this is that you basically, or what we did, is we made a giant file of all of the marks that we care about, converting to JSON using FazBuck. And when you commit, that just builds all your marks, and then they're cached. Simple, works. It was like, a few hundred milliseconds maybe on some requests, so it makes a difference. Another one is like scry unification. So for every scry you do, there's overhead. It has to pass through error and various other things, and all of that adds up. So if you're requesting 10 different requests all in one go and you need all of that to kind of make whatever view or UI you're trying to compose, you're going to hit that cost every single request. So what we did was basically like make one big data type and shove all the data in that, and then just do one scry. At least for the stuff we care about. Like, other stuff that happens later, like if it's not performance sensitive, then it's fine. But like, for that first like load of your app, or like you're coming back from, opening your phone screen, you need to be fast. So basically, this is all like, how quick can we get a single request to your phone or device or whatever? And so part of that, the best requests is the ones you don't have to make. So like we've added a lot of client-side caching and synchronization. So we're currently rewriting our mobile app in React Native, and with that we can use more powerful things like SQLite. And we just build basically somewhat of a mirror of your Urbit's data on your device. That way, like all your chats are there. You don't have to re-request them. We can keep track of what changes have happened, and to know like, okay, we need to refetch this because it was edited or whatever. That's kind of ongoing. We do have some on the current web client, but it's not the best. And then the final thing here is error caching. So something that, as far as I know, like only maybe like a few people really use, is the fact that error can cache responses, and they will just come straight from the runtime, and it's extremely fast. And so what we've been experimenting with was, well, what if you just did that for all the scries that we care about? And so, this took our request time from like 250 milliseconds to like 80, which is probably just the latency of the network connection. It's probably not even, it's like barely anything. So this hasn't been put into production yet, but it looks promising. I ran it on my ship and had like 200,000 like cache writes and never noticed anything. So
This is using Air's like static response.
yes,
Yep.
correct.
Right. Yeah.
And so the way this works is that we made like a little library, which basically like has like a debounce function. And so your ship receives updates, we hit that function, and eventually your ship stops receiving updates within a time window. The cutoff is probably needs to be like less than 5 seconds or something like that, but that will keep that response up to date, and now it's like lightning fast.
Interesting.
Are you doing this for, like, let's say, every group someone's in, whenever they're getting a message?
So that was just with listening to updates directly from the group's agent, which is generally like a new channel was created, group invites, stuff like that. We haven't completely put it on channel, like, messages or anything like that. It'll be interesting to see, but it seems promising. my ship didn't crash or anything. So, I mean, it was writing, basically about like, I don't know, 200 to 400 kilobytes every time. And there was like, 200,000 of those after, a few days or something. And it didn't seem to have any issue with that, so.
Yeah, I guess I know like my ship is generating a ton of writes
Yeah.
right now. So like if it did for every group, that would be a concern.
Sure, yeah. We're gonna test it and see. So yeah, I guess the next thing that kind of leads into this, so when we did this, we were actually playing around with the idea of like, well, what if we just talked with nouns over the wire and let the front end do the work? And so I'm gonna let Mark talk about that.
So one of the things that has been consistently kind of a rough, well, I wouldn't say pain point, but it's like a point of friction certainly when you're developing agents and you want them to talk to a client. Historically, this has always gone over HTTP. It continues to go over HTTP. Historically, air has always forced you into a position where, yes, you have all these beautiful marks coming as updates out of your agent, but those marks better have conversions to JSON. Otherwise, the client will not be able to access them. As of Zeus 412K, which is a while ago actually, this is no longer true. Air now lets you specify for any given channel that you open whether you want the output, the data coming over there as JSON, as traditional, or as jammed nouns. This means we can ship raw nouns directly to the client without having to do any of the JSON conversion on the back end. This is significant because even with, yeah, please clap. This is significant because even with the JSON serialization jets that were added recently, it's still so much work for the backend to be doing. We're talking hundreds of milliseconds for pretty normal, small scoped pieces of data. Compared to just jamming a noun and maybe converting that to like pet UW serialization, that's no work at all. It happens almost instantly. Even better, the bandwidth of that going over the network. A pet UW encoded jam buffer, so like an actual string of pet UW notation atom, is more than 50% smaller than the equivalent JSON in our cases. This depends, of course, on how you're like serializing your noun to JSON, but in most of the ones we've tested, it comes out over twice as small. If you then do a jammed byte buffer instead of pet UW encoding, it's half of even that.
I was going to say, is that it's even smaller than a gzip JSON? Or?
That's a good question. We should test for that.
Yeah, we should look.
And then test the gzip noun also. But
True. Well, the jam's pretty good. Right?
yeah, it's pretty good.
Yeah.
It should get most of it. But yes, you save a lot on backend serialization cost and bandwidth. Other question?
Yeah, I was wondering, like, how do you benefit from that in practice if you are doing stuff like React and React Native? Because isn't that just essentially not the converting on the front end? Like, if your front
Yes.
end is in JavaScript.
Yes, that's exactly where I was going.
You need Hoon.js, not just
Yeah, so
right?
the thing that we have is on the client side, we use the nocsyx library, which we don't really use for the noc. We use it more for like noun wrangling, right? But we have spent some time updating that to contain also all of the JSON conversion utilities that exist in the standard library. We just ported those over to JavaScript.
Is it Node.js?
Nocsyx, yes.
This is all public committed.
This is all public, it's all committed.
Yeah.
This does mean that, oh yeah, you're doing the same work, but you're punting it to the client. Now, in practice, your client is going to be faster than your Urbit for the time being. And it does mean that your client is going to have to understand the nouns. Now, this is not the most ergonomic thing in all cases, what we're doing for us in practice right now is we're just one-to-one porting the mark conversions to the front end, doing that work there, and then working with the JavaScript objects as we have been doing. There's potential futures here where you do that like in a very partial or on-demand kind of way, so you can like spread out the work even further, or maybe treat some sub-nouns as like opaque identifiers, stuff like that. Because yeah, you do also like, you don't just get nouns, you get to send nouns back to the ship also. Question?
So the one thing that you said there was that the client is going to be faster for now. Does that also remain true for like these like Node.js conversions? Like the browser is faster at converting JSON to not than the Urbit ship is? That seems surprising.
You save a lot on the serialization that you're not doing on the back end. The front end like unpacks into a noun object very fast, and then turning a noun object into your desired JavaScript object shape.
Oh, it's like the encoding and decoding stuff. Handling JSON on the server side is much slower than the
Yes.
equivalent thing on the browser, and that's actually the main benefit that you're getting.
Yes,
Is that,
yes.
that makes sense?
Yeah, you're moving like all the heavy lifting over to the client side. It's much faster with that. Yep, yeah.
So even if the client isn't good at converting to now, it's so much faster.
Even if the client isn't that good, as long as it's not completely idiotic about it, it'll be faster. Which it was initially. We spent some time like optimizing the queue implementation, but it's
the whole
fast.
thing.
It's fast. We would have liked to like have a whole talk about this actually. We've been doing regular like slow burn work.
6 months of weekly meetings.
6
like,
months of weekly
trying
meetings.
to do like 3 hours at a time.
Yeah, we've been trying to get it to a place where, yeah, we can start using this for our own production stuff. We're at the point where we're like trying some of that. The ergonomics aren't quite there yet, but we hope to be able to like present and deliver something about this properly in the near future.
Will Tlon ultimately transition to using these over marks, or how will that look?
We're not.
Because there are a lot of them on the front end for groups. There's
Yes.
a lot of marks that like this would kind of like sidestep, right?
Yeah. There is a world where we go all in on this. We're not committed to that just yet. We'll have to, work with it more and see how that plays out.
What about that format that Ted had like spec'd out at one point that was like a hybrid?
Ulam?
Noun? Yeah, Ulam, yeah. Is that,
What about it?
well, I guess it's like, would that be something that you guys would consider, or sort of like, in terms of the question, like as the kind of future, sort of potentially without marks, but like, or this superseding it?
I don't think that's strictly necessary for something like this. Like you just want to, like render on Earth that which is Earth. Mars should just keep speaking nouns, right?
I can say a little more about that actually.
Sure.
Ulam, the intent there is sort of like an Urbit, or sort of Urbit's answer to JSON is the intent. It's very similar to JSON, but basically you have atoms and auras, and instead of like JSON, scalars, and you have Kuhn lists and ordered maps as the containers. It's basically the idea that you can serialize it into JavaScript, or into JSON and back, but the things that where Ulam shines is when you have dynamically typed data, right? Just like JSON. It's like JSON shines when you don't know exactly what you're going to get, and you want it to be self-describing despite that, and maybe you know that you just want one field from it, but you don't know what it looks like other than that. For this kind of application, like what Tlon's building, they control the front end and the back end. They know exactly what types the data is on both sides, statically typed. So you don't really want to use Ulam really anywhere at all, or even JSON. Like you want something that's more like a static code.
Question back there?
Question is, when I use that, when noun transfer lake is very much like going, pull the exact access side of it out. Would you guys do that, or?
What we're doing right now is we have like almost exact equivalents of the NJS part of the standard library. So you're not doing it by access. You're like writing for the entire noun, for the entire object.
So you are converting it to JSON then to the. No, great.
No, we're taking a noun and turning it into an object of our desired shape.
Yes, you were pulling just an access out. Oh, that's awesome.
Yeah, yeah.
Cool.
All right. Hopefully some of this was useful to all of you. It's been quite a slog of just, running into new territory pretty much all the time and having no answer that we have to come up with ourselves. I think this will get better. But for now, we're trying to build a real product, and we can't let any deficiencies of the platform, get in our way. We have to build it, basically. And so, I don't know what else we were going to say at the end.
Good luck. Have fun.
Yeah.
So I know you guys have your hands full with, grappling with all this stuff and building what you're building. What would be the best way to turn some of what you just talked about here into documentation?
Ooh, I don't know. Mark?
Just write it. Like we did.
Great, I'm looking forward to it.
Yeah.
Yeah.
Right.
No. Like that's we did build all these things. We know how to work with them. There's in some of the libraries there's inline documentation. We should just spend
We could
a couple
stick it out
days.
on the documentation, talk to you guys, or could you?
Yeah, we can do a an outline or a rough draft, and then you have a ghostwriter cleaning it up.
Okay.
Be perfect.
Yeah.
That'd be cool.
Anybody else? Go ahead.
For the parts of it, if you're interested, for the parts of it that are not written, suspect LLMs will do a good job of writing the documentation for you if you want to snap that in.
Not a bad idea.
Yeah.
Ed?
That could be the ghostwriter.
I'm actually really curious because I run into this all the way at the other end, dealing with nouns in Rust, right?
Mm.
Working on areas. So, do you guys have any sense of what better ergonomics than here's a noun, greedily materialize it into your language's structs, and work with it from there? What noun ergonomics in a Terran language would look like? Have you guys developed any sense for that at all with it? Because I feel like I haven't, so I'm wondering if anyone else has.
A little bit. We haven't done enough of it yet, I would say. We wrote a bunch of helpers that kind of look like what JSON conversion looks like in Hoonside. And we found some patterns, even just the first object that we tried to convert, we found stuff that we could reuse and,
I have 2 ideas for that.
Okay.
I haven't tried, but
Okay.
we should talk.
We should talk about this.
I have to implement taxis and implement lists. We don't flag into the list.
I mean, I literally had to write get by.
right, yeah, exactly.
No more questions?
I shouldn't say I did it.
Awesome. Thank you all.
Thank y'all.